Finding slope using all three forms. The very first form we're going to talk about is finding slope from a graph. We talked about earlier that in order to find slope from a graph, we need to find the change in y and put that over the change in x. It's also known as the rise over the run. In order to find the slope of this graph, we first need to label some points on this graph. I can see that this point right here intersects nicely. This point also intersects nicely, and so does this point. So I have three different points to choose from in order to find my slope. I'm going to choose to use this point and this point. Doesn't really matter. You can use any 2 points on your line. Those are just the points that I chose to use. First, I'm going to find my change in y, or my rise. So my rise is up 1, 2, 3, 4. So my change in y is 4, or my rise is 4. My run is 1. So my change in x is 1, or my run is 1. So my slope is a rise of 4 and a run of 1. But I also need to look at my slope and ask myself, is this a positive 4 or a negative? You'll notice that if you look at your graph when reading it left to right, that it's decreasing. Because it's decreasing, I know that my slope is negative. So my final answer is a negative 4 over 1, or just a negative 4. Another example of finding slope from a graph is a graph like this. You'll notice that in this scenario, we have an example of a real-world problem where as your seconds are going by, your distance in miles is increasing. So we need to find the slope of this graph. In order to do that, I need to choose some points on this graph. I have a ton of points here to choose from. They intersect nicely, so any one of these points that I'm filling in, I can use. I'm going to choose to use these ones, but remember, it doesn't matter which points you use as long as they're on the line. First thing I'm going to do is find my change of y. If I started at 6 here and I went up to 8, I know that my change in y is up 2. If I look at my x value, I started at 30 and went to 40, so my change of x is up 10. Remember, slopes always need to be reduced, so my change in y over my change in x, also known as my slope, is going to be 1/5. But remember, this is a real-world problem, so it's not just 1/5. I have to interpret the meaning of the slope. This means that for every 1 mile I travel, it takes me 5 seconds. So this is my final answer of my real-world slope. Another example of finding slope is from a table. Remember, it's still the change in y over the change in x. In this case, our y is going to be temperature, and our x is going to be hours. Remember, the temperature depends on the hours, so temperature has to be y. Looking at y here, I went from -2 to 7, which means I increased by 9. I also did the same thing again when I went from 7 to 16. I went up by 9. If I look at my change of my x's, I went up by 3, and then I went up by 3 again. So my slope from my table is 9 over 3, which reduces to my final slope of 3. But remember, this is a real-world problem. So this is 3 degrees every 1 hour. So now we've talked about how to find slope from a graph and how to find slope from a table. Now we're going to talk about how to find slope from 2 points. Remember that slope is m, okay? And the formula to find slope of 2 points is y2 minus y1 over x2 minus x1. It could also be y1 minus y2 over x1 minus x2. All right, so let's go ahead and work on finding the slope from these 2 points. I'm going to first label my points so that I know how to plug them into my equation. First things first is in a coordinate point, it always goes x, y. So this is going to be x1, and this 5 is going to be y1. 9 is going to be x2, and 8 is going to be y2. I'm now going to find my change of my y over my change of my x. In order to do that, I'm going to solve for m, which is my slope. 8 minus 5 over 9 minus 12. When I simplify that, I get 8 minus 5, which is 3, over 9 minus 12, which is negative 3. We always have to reduce our slope, so our final answer is 3 divided by negative 3, which is a slope of negative 1. All right, going to find slope from these 2 points now. Again, I'm going to go ahead and I'm going to label my points x1, y1, x2, y2. And I'm going to subtract. 3 minus a negative 1. Remember, it's a negative 1, so it needs to be indicated. Over 0 minus 5. If we think back to integer operations, we can go ahead and LCO our top portion of our slope. And we know that 3 minus a negative 1 is really 3 plus a positive 1. And 3 plus a positive 1 is 4. Looking at our change of our x, we have 0 minus 5. And 0 minus 5 is a negative 5. So my final slope is 4 over negative 5. You could also rewrite this slope as negative 4 over a positive 5. Or you could say negative 4/5. This is all the same answer. All right, we have another set of points we're going to find the slope of. I'm going to go ahead and label my points. x1, y1, x2, y2. And we're going to find the slope of our 2 points. 0 minus 3 is the change of my y over negative 1 minus a negative 5. Simplified, that will get me 0 minus 3, which is negative 3, over negative 1 minus a negative 5, which is the same thing as saying negative 1 plus a positive 5, which we know is a positive 4. So my final answer is a negative 3/4. Another set of points to find slope from. I'm going to go ahead and label them x1, y1, x2, y2, and find my slope. Negative 1 minus a negative 7 over negative 8 minus a negative 3. If I simplify this, I'll get negative 1 minus a negative 7, which is the same thing as negative 1 plus a positive 7, which is a positive 6, over negative 8 minus a negative 3, which is the same thing as negative 8 plus a positive 3, which is negative 5. So my final answer is 6 over negative 5. Going to find slope from these 2 points, x1, y1, x2, y2. I'm going to find my slope. Negative 1 minus a negative 1 over negative 2 minus 4. If I simplify this, I'm going to get negative 1 minus a negative 1, which is the same thing as negative 1 plus a positive 1. That's going to give me 0. And for my denominator, I'm going to get negative 2 minus 4, which is the same thing as negative 2 plus a negative 4, which gives me a negative 6. You'll notice that right here in my numerator, I got a value of 0. If this happens, my slope is 0. This is a nice horizontal line. The slope is 0. That is your answer. You would not write your answer as 0 over negative 6. You would write your final answer as the slope is 0. All right, last set of points here. x1, y1, x2, y2. All right, we're going to get started. Negative 6 minus 0 over negative 7 minus a negative 7. When I simplify this, I get negative 6 over negative 7 plus a positive 7, which is 0. You're going to notice that this time the 0 was in the denominator. Because of this, your slope is undefined. You would write your final answer as the slope is undefined. All right, let's recap. We know that the slope of a graph is going to be the change of y over the change of x, which is also known as rise over run. If we're given a table, it's the same thing. It's the change of y over the change of x. When we're given points, we know the formula is m is equal to y2 minus y1 over x2 minus x1, or you could say y1 minus y2 over x1 minus x2. Remember that if you ever have a fraction like 0 over any number, the slope is 0. If you have any number over 0, the slope is undefined.